In this video, we're going to be demoing just a couple of built-in math functions that are built into Java. I think I'm going to be demoing maybe 3 of them just to show you how they work, and I'll show you how you can look up the list of all of the other functions that you can use as well. So let's get started. Let's go to a new project, Java application, and we'll call this math demo. And I will use the scanner class in order to get my input as well for these numbers. So let's go ahead and get started. And just going to clean up my comments here. Okay. So in this program, I'm going to demo, for sure, I'm going to demo square roots, exponents, and maybe absolute value. Okay, so first thing I'm going to do is I'm going to create my scanner class. So scanner, I'm going to call it input equals new scanner, and attach to the system.in. That's just going to allow me to use the keyboard properly for my input at least. Now this thing here, I'm going to have to fix my imports. Right click and then fix the imports. And let's just go double num1, something like that, because I'm going to be getting information from the keyboard. I'll just go with num1. Now let's do square root first. First thing we'll do is do a little prompt for the user. Print, please enter a number to square root. That. And then let's go num1 equals input dot next double. Oops. Oh, why does it say hash code? Well, let me try that again. Dot next double. There we go. This will be fine because in a previous video I had to switch these all into input.nextLine and I had to convert them. Because I'm only going to be working with numbers in this case, it's not really an issue if I keep using next double. So it should be fine. If it does act up, then I may have to go back, and this is a previous example I did. I had to go and switch everything and make it go double.parseDouble of input.nextLine. This issue came up because of the fact that I was trying to get a string as well. As soon as you start mixing strings and numbers, that tends to happen. If you only work with numbers, it's not a problem though. Okay, so let's do this first here. So we've got our value inputted with the keyboard. Now to print the result, here's what I can do. Let's go, let's create another variable called result. Oops. Result equals, now to square root it, what I'm going to do is go math, the capital M, dot, sqrt. And what am I going to square root? num1. And then finally I'll print this out. The square root of, and I'm going to attach in the input right here, so plus num1. And then I'm going to put equals, just like that. And then I'm going to attach in the result. So it'll print this phrase, the square root of, whatever I typed in the keyboard at the beginning will go here. Then an equal symbol comes up, and then it'll print out the answer. Let's try it out with a number I know. Square root of 81 is 9, obviously. And make sure this thing works. So 81. Square root is 9, perfect. Okay, so there's a demo of the square roots. Works pretty easy. There's not really much to say other than the function you need or the method you need is called math.sqrt. Okay, next one let's do is exponents. Now for exponents, I'm going to need actually 2 values. So you know what? Let's create num2. I need a base and an exponent. So let's go with that. So, sorry, one sec. Put a little comment there. This is the exponent part. System out print. Please enter a base. And then we'll say num1 equals input.next double again. And we'll do the same thing. Please enter an exponent. And then we'll get that for num2. And finally, let's actually apply some math to that. So result equals math dot. Now here's the list of all the math stuff built into Java. So every function you can imagine is basically in here, and you got to really pay attention to what the input is. That's the thing in the brackets, and this over here is the output. So like for example, if I'm going to use cosine here, this is cos, right? It needs me to send in a double as the input, and it gets back a double as output. Those are really important to notice sometimes, because sometimes you have to send in an int, or you try and use an int and you have to send a double in, things like that. So pay attention. Doubles usually do work, and the one that we want actually is, in this case, it's POW. Most of the time, people, if they make a mistake here, they use this thing. They use EXP. They think it's going to be this one. But if you actually look at the definition of what EXP is, it's Euler's number e raised to this power. This is not what you want. What you actually want is this one called POW. Returns the value of the first argument raised to the power of the second argument. One thing you got to realize, a lot of times we call these things exponents now, right? 2 to the exponent 3 is 8. But if you went back 20 years, a lot of the terminology we use as power, we used to say 2 to the power of 3, and I believe that's where the method name came from. It's from a little bit of a dated version of that. So that's what you want. You got to use math.pow, and you send it 2 numbers, and you get 1 double back as your answer. So let's try it out. So let's put num1 as the base, num2 as the exponent, and then we'll print this out. Let's go like this first, actually. Num1 to the exponent. I'll put num2 equals and result. So it should say num1 to the exponent, num2, then the equal sign, and then the result. So let's try doing 2 to the exponent 3 and make sure it actually works. It should say 8. Oh, I gotta do this thing first. Okay, so the base would be 2, exponent 3. 2 to the exponent 3 is 8. Perfect. Alright, so we got exponents working now. And you also, if you wanted, you could do something like, you don't have to use variables, obviously. As an alternative, you could just go 2 comma 4, something like that. That would work no problem as well. So it doesn't have to be a variable. I'm just using a variable in this case, but this is how you would do it. If you knew the exact numbers, then it's never going to change, right? So this would be 2 to the exponent 4. You would do something like that. Okay. Just make sure you're not doing this. 2 to the exponent 4. In some languages, that is the correct way of doing it, but not in Java. It won't work properly. You have to use math.pow. Okay, last one here. Let's do absolute value. Now, what absolute value does, essentially, is it basically removes the negative from any value. So if you had the absolute value of like -8, it just becomes 8. That's all it does. And the positive value, like if you had the absolute value of +8, it stays +8. So literally all this function does is it drops a negative. Now why is that actually useful? Right? What it does is, imagine I was gonna like do something like this. So 5 minus 3, right? We get an answer of 2, right? But what if the user messed up and I put a 3 first, then a 5? If I did that, then my answer would be -2. But maybe what I really want is to know how far apart the numbers are. So what I want is the distance between these two numbers, right? I get two different answers depending what order I put them in, right? But if I use the absolute value of this, then they're both going to say 2. So that's the whole purpose of this function. It's used a lot of times in like physics and stuff like that, where I want to know the distance between 2 points, but I don't really care which point's on the left side, which point's on the right side in terms of a number line. We just care about the quantity between them, the space between it. Okay, so let's try this out here. So system out print, please enter a number to get the absolute value of something like that. And then we're going to say no, we'll use num1 again. Next double. And then we can do that. Result equals math dot. The only one is ABS. Okay, now ABS, this might cause a problem. Oh no, there is a double version there. I was looking, there's 4 versions of the absolute value, ABS. You can send it a long, you can send it an int, a float, or a double. The one we're going to use is going to be the double, so that's not going to be a problem. So it's going to be the absolute value of a double. You don't have to even click it, but just going to be absolute value of num1. That's what you got to do. Oops. And now we'll print this out. The absolute value of num1 equals result. Okay, let's go ahead and try this out. Okay, it's 81. Yep. 3 to the exponent 2 should say 9, right? Good. And let's do the absolute value of -25. It should say +25. That's exactly right. Let's run it again with a positive number, make sure it still works correctly. Sorry, I just moved this up a bit here. Let's try some with decimals, make sure it actually works. Yep. Okay, 2 to the exponent 3 is 8, and +9. Yeah. So you can see there. So the absolute value, all it literally does is drop the negative. And I don't use that very often, but sometimes it's like really important to be able to do that. So it's a simple little function, a little method there called absolute value, but it's really, really useful in some situations. So anyways, this is just a little demo of a couple of the more advanced math functions that are built into Java. And there's more, obviously, you know, like if you use the code completion in NetBeans and take a look, there's probably about 100 here. And some of them are super useful, like floor, that's a very useful one. Your cos, tan, sine, those are very useful. Keep in mind though that this is going to be in radians. So this, you need to send in radians. So if you're used to sending in degrees, that's going to be an issue. So there is something called 2 radians. You can send in a number and it'll convert it to radians for you. You might need that if you're going to use sine and cosine, stuff like that. What else is there? It's useful. Min and max. You can send in 2 numbers and it'll spit out the biggest one. Very, very useful, or the smallest, right? Logarithms, you can do that. Basically, anything you do in a scientific calculator, you can do with this. Pi, if you want a precise version of pi, there you go. Use math.pi. So don't use 3.14, use this thing, math.pi, like that. So anyways, you know, I could spend forever, you know, talking about this stuff. Just go through, you know, if you ever need something, just find what you need in this list, and it's pretty easy once you get going with it. Not too bad. Anyways, just a little demo of some math functions in Java here.